Hi, welcome to another edition of Algebra 2. I'm Mr. A, and today we are here in section 2.7, and we're going to talk about parent functions and transformations. Parent functions, it's just basically there's a few types of graphs that their parent function is kind of like the basic function, and then the transformation is depending on what numbers get added or subtracted or whatever onto that basic equation and that basic graph. It'll be how it moves it, basically, is what we're looking at today. So here's our objectives. First of all, we're going to identify and use parent functions. And then number two, we're going to describe those transformations. Okay, and again, transformation is how it changes. All right, so let's take a look at some of these. Here are the parent functions that we're going to be dealing with today. First of all, let's look at this constant function here. It's just a line that goes straight across. And if you notice here, it says its equation is y equals 1. And we've been talking about that before. I've mentioned that before. Anytime you have y equals a number, it's just going to be this constant function, just a line straight across. So no matter where you move that to, if it was down here where y is -2, your equation would be y equals -2. So it's just going to be a number there. If you notice here, the domain is going to be all real numbers. Again, domain is left and right, so we're using all the x's going left and right, so it's all numbers. The range, remember, up and down is the range. That's the y's. What y's do we use on that graph? The only y we use there is 1. And if we drew another one down here at -2, the only one we would use there is -2. So it's just going to be one number. We're not going to really talk about this function throughout the rest of the video here today, because pretty much the only way you change that is just move it up and down, basically. And so we'll kind of deal more with these other ones here. The second one is identity function, which is linear. That is a straight line. And the parent function there is y equals x. That means it's going to start at 0, 0. It's going to go up 1 and over 1, up 1 and over 1. Okay? So it's always going to go up 1 and over 1. So that's a slope of 1. Both the domain and the range are going to be all real numbers. Okay, so we're going to use all the x's going left and right. Going up and down, we're going to use all the y's going up and down. Then there's the absolute value function down here. You always can notice an absolute value function when you see it makes a V shape. V for value, V for value, V for value. And it's going to be the parent function there is y equals the absolute value of x. It's going to start at 0, 0. It's also going to go up 1 and over 1. And then, of course, going to the left, instead of up 1 and to the right 1, it's going to go up 1 and to the left 1. They'll both have the same steepness, but just going both directions. The domain, the x's going left and right, we're going to use all the x's going left and right, so all real numbers for domain. But going up and down for range, where does this graph? It's only above 0 on the y's. So the only y's we're going to use are the y's that are greater than or equal to 0 on this parent function. And then the last parent function is quadratic, and that's always going to make a U shape like this. Its equation there is y equals x squared. And on this one, it's always going to go through 0, 0 there, the parent function. As it goes up both directions, it's going to be the same, where it's going to go through this point of like 1, 1 or -1, 1, and then 2, 4 or -2, 4. It's going to look like that. Again, the domain is going to be all real numbers because these arrows will keep going to the right. So we're going to use all the x's going right and left. But the y's, the points we use on this graph, are all above 0. So again, the range is y is greater than or equal to 0. Okay? So let's take a look at a few and see if we can figure out what type they are, first of all. All right, so let's look at this graph here. What kind of graph is that? Well, if you notice, it makes a V shape. So this is absolute value. Okay, that's all we're looking for there. How about this one? That graph makes a U shape. So can you remember what that kind is? That's a quadratic. Okay, good. So that's a quadratic function. Okay, a line that goes straight across there, a line that goes straight across. What kind of function is that? Here's our choices. We got some choices this time. Is that an absolute value? Does it make a V? Nope, it's not that one. Remember the quadratic we talked about makes a U. It's not that one. So is it an identity or is it a constant? It's a constant. And so you notice that's where it's straight across. And this one here, the equation, what would the equation be here? It would be y equals 2. Would be the equation on that one. And then the last one here, if you hadn't figured it out by now, this is the one where it starts at 0, goes up 1 over 1. That's the D identity function. Okay? All right, so now let's get into transformations a little bit now. Okay, now we're going to start talking about transformations a little bit. Here are the different transformations that you can get. These are the different ways that it can change. It can either be a translation. A translation is going to move your graph, that parent function, left or right, up or down. Okay, so that's translation, is moving it up, down, left or right. A reflection is going to flip the graph over a line called the line of reflection. So it's either going to take your graph and flip it down across the x axis, or it could also flip it sideways across the y. And we'll get into that a little bit more too. And then the other thing is a dilation. It's called a dilation, and that's going to either shrink or enlarge the graph. It's either going to stretch it out or kind of flatten it, basically. All right? All right, so let's talk about how this happens. I think it's easiest probably just to talk about each type of function and look at the ways that it can be affected that we were just talking about with dilations, translations, and reflections. Okay, so here's a linear function. Okay, linear function, in this case this is the identity function, y equals x. Okay, so how are the different ways that this can change? Well, remember our good old y equals mx plus b. Remember one of the most famous formulas in all of math? If you remember this here, remember that b, that's your y-intercept. And remember what's m? M is the slope. Okay, so I wanted to start with this one because you're more familiar with this. So those are the things that we know about, the slope and the y-intercept, and that's what's going to affect our line here, okay? So let's look and see the first thing that could happen. Okay, so what we did on this one is we added 4. So the y-intercept is 4 now, right? And so instead of y equals x like we have up here, we have y equals x plus 4. So what do you think is going to happen to this line? Remember up here on this parent function here, this counts as y equals x plus 0. That's where it went through. It went through 0 on the y. So what do you think it's going to do now? It's going to go through, what, 4, the y-intercept of 4. So here's what that line is going to look like. Notice the slope is the same. It still goes up 1 and over 1. All we did was we just moved it up. Okay, so that would be a translation. We just moved it up. If this would have been a negative 4 here, x minus 4, we would have just moved it down 4 instead. Okay, so that just moves it up and down. All right, what else? Well, now in this case, I've got a couple of things in there. Well, you notice instead of plus 4, like we had here, we have a minus 4. So we know that's going to move the line down to a negative 4. But what else? Well, there's also this 1/4 here. So remember, if you remember the slope is rise over run. So that means this 1 over 4, it's going to start at negative 4 and it's going to go up 1 and 4 to the right. So it's going to look like this. So what did that do? That basically that kind of flattened it, right? So instead of stretching it out up and down, it flattened it. Okay, so this would be this is a dilation, and this would be what we could call this compressing that vertically, compressing it vertically. It's making it with a shallower slope. All right, one more here. We have y equals a negative x. So all we changed from the original parent function up here to this one is we put a negative in front of the x. Well, this is where we have the reflection, okay? If you have the negative basically in front of the whole equation there, it reflects it across the x axis. If the negative is just on the x, the variable of x, then it would reflect it across the y. And in this case, actually, because of the way it looks there, it kind of actually does both at the same time. So here's what it looks like. It's going to look like that, and you go, well, that makes sense because you know on our equation here, the y-intercept is still 0, but this is a slope of a negative 1 over 1, so that means we would go down 1 and over 1, down 1 and over 1. Well, and if you think about this, and it's a little tricky here, but think about the reflection here. If you think about the x-axis is your line of reflection, this part of the line up here, the black part up here, it reflected across the x to be this part of the green line. And this part of the black line that was down here got reflected across the x to be the upper part of the green. And like I said, if you think about reflecting across y, think about it reflecting across up and down. Well, this part of the black line could have reflected over to this part of the green line, and this part of the black line down here could have reflected over to that part of the green line. So in this case, it's a little strange, but it technically is kind of both at the same time in this situation. It won't be as tricky when we get to the other types of equations as far as the reflections. Okay, so that's linear functions. Let's look at absolute values. Here is the parent function, y equals absolute value of x. And you notice it's going to start here at 0, 0. It's going to go up 1 over 1, up 1 over 1, both directions. Now, okay, this is going to look a little scary at first, but it's really not that bad. Whoa. Okay, let me just explain a few things. Basically here, you're going to see this h and k more later on. But it really is, I wanted to start with the linear because you're familiar with y equals mx plus b. But here, there's a couple of things that are a little different, but it's really the same thing. Remember the b plus b? That's really the same as plus k. It's really the same concept, and we'll see in a minute. So just because it's a k, don't get freaked out. It's just the same thing as plus b. And remember the m for slope in front of the x? That's really the same thing as the a here. The a is just what's in front is kind of like the slope. The only thing that's really new or different is we also will have this h in here in the middle with the x, and I'll explain what happens with that. Okay, so let's start out here with the k. What happened in y equals mx plus b when we put a number out here? It moved it up. We went up 4 units. So it could move it up or down depending on if this is plus or minus. So let's look and see what would happen here if we just had the absolute value of y equals the absolute value of x plus 4, just like we did before. Well, before it moved the whole line up 4 places. What do you think it's going to do here? It's going to move it up 4 places, okay? So it's going to look like this. Look, it's the same graph. It just moved it up 4 spots. So that works the same way as linear did. Okay, just moved our graph up 4 spots. Now, okay, here's where the h inside comes into play. If you notice here, I got a couple of things on this one. You notice we have a plus 2 here. Well, basically from what we've seen, we know since this moved it up 4 for the red one, this plus 2 is going to move the graph up 2 on the yellow. Okay, so we know that. We've seen that before. What's this 3 in here going to do? A little tricky, but this is going to move it left and right. And so you might think, oh, great, okay, that'll move it 3 to the right. That's where it's tricky. It's actually kind of opposite of what you have in here. That's why I have this written as x minus h. Because if you think of this as x minus a negative 3 is the way that it's actually going to move. So it's kind of, just remember whatever sign this is in here, if this is plus 3, it's going to move it 3 to the left. Okay, so outside, plus is up, minus is down. But inside, if it's plus, that's actually to the left. And if this was x minus 3, it would actually move it to the right. So in this case, we're going to move it up 2 and 3 to the left. Here's what it looks like. Notice from 0, 0 over here, we moved it up 2 and 3 to the left. Same graph, but it just got moved. Okay, so far okay? Let's look at the next one. Okay, on this one now, you notice there's no plus or minus a number out here, so we're not going to move this one up or down. Okay, so it's not going to get moved up or down. But the minus 3 in here, what's that going to do? It's going to move it, what, 3 places to the right this time. Okay, so we're going to start where the point is at 0, 0, and we're going to move it 3 to the right. So the point of this new one is going to be over here at positive 3. Well, the other thing that's going to change some stuff here is this minus 2. First of all, the minus, since this is out front of the whole thing, it's not just on the x, it's going to flip that black graph, it's going to flip it where it's going, instead of V and the arrows are going up, it's going to go where the arrows are going down. So it's going to flip it upside down, move it over to a positive 3, and the other thing is too, remember like in y equals mx plus b, if you had a slope of 1/2, if you had a slope of 1/2, then your line would go up 1 and 2 over. It'd make it a little flatter. But if you had a slope of 2, in this case we have a negative 2, but 2 or 2 over 1, it would go up 2 and over 1. It makes it steeper. So this one's going to make it steeper. It's just that it's steeper going upside down. So here's what it looks like. So you notice, if you can, and you'll see in a second when I do one more here, it'll be easier to compare. But you notice how wide this black one is here? It goes up 1 and over 1, up 1 and over 1. See how wide it is? But on this blue one, even though it's upside down, notice now it, instead of going down 1 and over 1, it goes down 2 and over 1. Down 2 and over 1. So it's a little narrower than before. So it's not only narrower, but it got flipped upside down and it got moved over to a positive 3. One more. Y equals negative absolute value of x. So this negative is outside of the absolute value, so it's going to flip it upside down just like the last one. It's not going to move it left or right, but it's also not going to make it skinnier. It's going to be the same width as that black one, so it's going to look like this. Now I think you can see, it's easier to see that this green one is a lot wider than that blue one. So all we did on the green one was we just flipped that black one upside down. Okay? So there's a few of the things there with absolute value functions. We got one more type of function to look at. Quadratic functions. Here is the parent function for quadratic, y equals x squared. And this is what the graph is going to look like here. It's going to start at 0, 0. It's going to go up 1 and over 1. Okay, it's kind of hard to get these lines to hit exactly on these dots here, but you basically get the idea here. It's hitting at 1, 1, and then at 2, 4, it's hitting here. Same thing, negative 1, 1, and negative 2, 4. Those seem to hit a little bit better. But that's basically what that graph is going to look like. Okay? Look at this. We have pretty much the same thing that we did with absolute values, except for instead of absolute values, we have the parentheses. All the same stuff is going to hold true. Okay, so same thing, same kind of things. So let's look at the first step. Well, look what we did here. We don't have an h, we don't have a number here in with the x, we just have the x squared. We don't have a number out front. All we have is plus 4. What do you think that's going to do to this graph? If it's outside, this k outside is just going to move it up or down. And in this case, it's going to move it up 4 units. So it's going to look something like that. Okay, makes sense? You starting to see the pattern here? All right, yellow. In yellow now, we've got a couple things. Notice we have the plus 2 out here. So what's that going to do? It's going to move it up 2. What's this plus 3 in here going to do? Remember, this is where it's opposite. So it's going to move it to the left 3. So it's going to go up 2 and 3 to the left. So it's going to look something like this. Okay, that one's a little further off, but that's, you get the idea. All right, next. Now look at on this one, we do not have a number out here for k, so that means we are not moving it up or down. But this -3 inside here, it moves it which way? 3 to the right. This negative out front is going to flip it upside down, and then the 2 is going to make it narrower. So it's going to look something like that. So moved it 3 to the right, flipped it upside down, and that -2 made it skinnier. Or it stretched it horizontally, is what you might hear them say, stretching it horizontally. And then the last one here, this is a negative x squared. So here all we did was we just basically flipped it upside down. We didn't move it anyway, we didn't stretch it, we didn't compress it, we just flipped it upside down, and so that's going to look something like this. And you notice here this green one is a little wider than the blue one, because we didn't compress, or we didn't stretch it here with the 2. By the way, and this is, you know, most of these that we've shown here, with the negative, it flips it across the x axis. But if this would have been, just so you know, like this here, if this would have been, say, y equals a negative x squared, if it would have looked like this, since that negative is only on the x, not out front, this is the kind here where this one would have been reflected. This would have been reflected across the y-axis. So this is the kind where it would get reflected. And actually, and if you have, in this case, the parent function there is that black graph, if it reflects across the y-axis, what happens? Well, this part of the u over here flips to the other side, and this part of the u flips to the other side, and you know what happens? It's basically the same graph. You go, oh, that's weird. But look at this. If you have a negative x squared, what's a negative times a negative? A positive x squared, just like what we started with. So you can see, oh yeah, that kind of makes sense now. That if that negative's inside, basically kind of stays the same graph. So, okay? All right, so we're going to finish out here just with, let's look at a few transformations and see if we can figure out what's going to happen with them. Okay, so let's practice it here. Example number 1. Here's our equation. It's y equals x plus 1 squared. What's going to happen in that translation? Okay, we've got the plus 1 here. That's inside the parentheses. So which direction is that going to go? Remember, if it's inside, this is where it's opposite. So this is going to go 1 to the left. It's going to move it 1 to the left. So as this says here, basically translates it left 1 unit. And here's what the graph would look like. So the original parent function is the blue. Starts at 0, 0. We have the same function. We just moved it to the left one. All right, example 2. Absolute value. What kind of shape is this going to be? This is going to be a V shape, right? Okay. Now look at where this, you got a -4 here. It's inside the absolute value, so that means that's where it's going to move it left or right. If it's -4, is that going to move it left or right? It's going to move it, this is where it's opposite, move it to the right 4 places. Whoops, I kind of jumped the gun there, didn't I? Well, here's your choices. And as I just said, there's going to move it to the right 4 units. And as you can see, that's C. And so the graph would look like this. Original parent function here is the blue, and it just moves it 4 to the right because of that -4 there. Okay, this time, now we have, this is a quadratic function, and we want to talk about the reflection here, and I think I have multiple choice here, so I'm going to go ahead and hit it. Yeah. So what happens here? What's different? All we've got that's different is this negative out front, right? Okay, so it's going to reflect it. We know it's not going to reflect it across x equals 1 or x equals -1. Just forget about those. It's either going to be A or B. So does it reflect it across x or y? Well, remember what I said in that previous couple of slides ago. For this to reflect it across the y-axis, this negative x would have to be in parentheses and then raised to the second power, because that would be just the x to the negative. But in this case, and it's a little tricky, but this is really just means this is like -1 times x squared. So it's not just the x being squared, it's the x, or it's not just the x being made negative, it's the x times the x being negative. A little tricky, but just keep in mind, if it's not in that parentheses, then it's going to be reflected across the x-axis. So that's A. And it's going to look like this. Your original parent function there is the blue, and then when you reflect it across the x, you can see it turns it upside down there. How about this one? We're dealing with a dilation here, okay? So because we have a number out in front, this is absolute value because we have absolute value bars. What's that 1/2 going to do? Is it going to stretch it out and make it longer and taller, or is it going to flatten it and compress it, make it kind of shorter? Well, remember, think about slope. If you had a slope of 1/2, what does it do? It goes up 1 and 2 to the right, as opposed to up 1 and over 1. So what does that? It makes it flatter, right? Less of a slope. So it compresses that graph vertically, and it would look something like this. Notice the original parent graph here starts at 0, 0, and it goes 1, 1, 2, 2, 3, 3. This is the original parent graph here. Something like that. If I can draw that straight. You get the idea. So anyway, it compressed it vertically. It made it flatter. All right, last one here. Ooh, look at all that stuff. Okay, there's a bunch of things going on there. So let's kind of look through those. We do have some choices here. So let's kind of look through and see. Now remember, this is the kind here that I always say that the ACT and the SAT will try to like trick you. Because look at, there's the key word, there is not. So we're going to find out which one of these things is not right for this equation, and that's the correct answer. All right, so let's start with this -1/4 out front here. All right, -1/4. If it's out front, what's that negative going to do? First of all, it's going to flip it upside down, and then the 1/4 is going to make it flatter. Well, let's look and see what it says here. 1/4, -1/4 reflects it across x. Yeah, that negative is going to flip it down. That's reflecting it across x. So that's correct, which means that's not our answer because we're looking for the one that doesn't. What about this -2 out here at the end? Okay, what does that do? Remember, if this number at the end is going to move it up or down, and so if it's -2, that means it's going to move it down 2 units. Well, what does it say there? -2 translates it down 2 units. So that's correct. So since we're looking for the thing that is not true, that means this is not our answer. So we're down to either A or D. Both of them are dealing with the +4. And this one says it goes right 4, that says it goes left 4. So which one's correct? Since this is +4, remember this is inside the absolute values, and this is where it's kind of backwards. So since it says +4, that means it's going to move it what? 4 to the left. So that means our correct answer. All right, so here we are back again. I think what happened was I went ahead and hit the thing to get the red dot to come down in, and I confused myself. I think because we were talking about that if this is +4, remember it's opposite, and so if that's +4, it's going to move it to the left 4 units, which means that this one is correct. So it's not the answer. That the correct answer is the one that is not, if you remember, correct. And so A is the correct answer because it's the one that is not the correct translation or a transformation of this function. So I was trying to warn you about it, that it's tricky with the not, and then I got a little confused myself. So it just kind of goes to show you, be real careful on that. All right, and then here's what the graph would look like. You notice the blue graph here, that's the original parent function. So what did we do? This -2 moved it down 2. and then this plus 4 in the middle moved it to the left 4, and again that's, you know, going from the point here, we went down 2, 4 to the left, so now the point is here, and then that negative flipped it upside down, so that's why it's upside down now, and the 1/4, instead of going down 1 and over 1, down 1 and over 1, like this was up 1 and over 1, it's now down 1 and 1, 2, 3, 4 to the right, and down 1 and 4 to the left, right and left. Okay. All right. So that's it. That was parent functions and some of the transformations that you can get from those. And thanks for being here. We'll see you next time. Bye.